Hello! In this episode, we will take a close look at the quality check tool that has been implemented in INCISIVE project to ensure that all data uploaded to the federated or centralized node, including DICOM files and Excel templates, are homogenized, share the same principles, and follow the harmonization rules defined in the project. In this video, you will learn how to use the quality check tool, interpret the results, review them offline, and how you can proceed to corrective actions to conform with the project's requirements. If you need more information and to discover what sets the quality check tool apart, you can read the scientific publications that describe the tool in more detail. Let's start.
All you need to do prior to the tool's use is to have Docker installed and download and run the tool image. Open a web browser and type the provided URL. Insert the credentials and click OK to continue with the tool's content. Click on Select a folder to choose the data needed to be analyzed. The directory tree of the computer appears, and then you have to select the parent folder where the data lies, meaning the images and the Excel file. Then the first component of the quality tool starts to run. This component checks only the clinical metadata. When the analysis of the data is finished, the results appear into tabs named Structure and Codification, Content Validity and Template Consistency. In the first tab, you can see errors related to the template structure and the patient encoding. In the second tab, you will find errors about the content of the template, meaning the values inserted in its field. For each patient, you can see the fields of each tab where an error was detected. In the third tab, the tool checks the consistency among insertions in the template, and if inconsistency is found, the error is marked in the table below. Then you must click on the second component named Case Completeness, and the results appear in two tabs named Clinical Metadata Completeness and Imaging Data Completeness. In the first tab, the component checks the completeness of the clinical metadata and reports for each patient, and for each tab the missing mandatory fields, as well as the percentage of completeness for each patient. In the second tab, an overview of the imaging data is provided, and the tool reports what modalities are provided in each time point for each patient. The third component, named Template Image Consistency, checks if the file structure of the images is compliant to the template and performs a proper renaming of the study's folders so they can be stored in a unified and commonly understandable way. In case of inconsistency between the template and the folders, a message appears for the specific patient. If the folders were renamed properly, no message appears. The next component checks whether identifiable information appears on the DICOM images. 3 different tabs appear on the screen. In the first tab, you can select the de-identification protocol, which corresponds to the data collection phase, as well as whether the type of checking in terms of volume of files to be checked. Once the process is completed, the 10 most common issues related to the de-identification of the images as displayed in a bar chart and more details are provided in a tabular format below, including the path of the image and the identified problem. Based on the results, you must proceed to the required actions until no de-identification issues are reported. If a DICOM file is inaccessible due to reasons like invalid format, preventing identification check, it is listed in the second tab. The third tab checks for burnt-in information on DICOMs. If a DICOM report is detected, it's flagged for removal. If an actual DICOM image is found, a prompt to replace image appears. The image must be replaced with a cleaned image placed in the folder reported by the tool. When you select the next component, named DICOM validation, a process is initiated to check if the DICOM files are valid, in terms of missing any attributes or having any unexpected ones. The validation of the DICOM files may be crucial for some applications, which do not operate correctly in case an invalid DICOM file is provided or some attributes are missing. The most common validation problems are depicted in an interactive bar chart. The last component of the quality tool targets the annotation files, and it includes 2 tabs. In the first tab, a table lists the annotation files found. The component confirms if each annotation file is in the anticipated folder within the series folder. If a cell in the series column is marked, it indicates the annotation file is not within a series folder, obstructing the association between the annotation and the image folder. Additionally, if more than one annotation file is present in the folder, the corresponding rows are highlighted in orange. Moreover, The component ensures both the consistency between the image and the annotation file region of interest, and the number of images and their respective annotation slices. In case of an inconsistency, the respective cell is marked in red. Furthermore, given that the annotation file must include specific labels corresponding to the cancer type and imaging modality, the component checks for the presence of correct annotation labels and flags any invalid value. Finally, the component verifies the agreement between the provided files and the information outlined in the template file. If a cell is highlighted in red, a specific action must be made to ensure consistency. In the second tab, interactive visualizations provide more details related to the annotations and their distribution across the time points or the imaging modalities. Thank you for watching this video through the capabilities of the INCISIVE Quality Tool Check. Should you need any assistance or request a demo for the Quality Check tool, you can contact us in the emails shown on the screen.